Bueno, vamos a empezar entonces la última.
Okay, let's start our last session for the day. The conference is not finished yet. We still have dinner in the evening and tomorrow's session, but it is indeed the last session of the day. My name is Gonzalo from eCarton. Some of you already know me. I had a little talk yesterday and I'm going to speak today too, but I'm going to chair the panel. Let me introduce you to the members of the panel. Pedro Robles and Juan Daniel Castillo come from the Polytechnic University of Catalonia. They have a joint presentation about the conceptualization of the integration of collective and artificial intelligence with i3Geo. And then we have i3Geo, who is going to talk about urban planning and GIS systems. And finally, our Argentinian colleague, Marta, she's going to talk about gvSIG in her country, a successful story. They have 25 minutes each. Let's try to be good. Let's be good with time. Good afternoon. First of all, let me thank gvSIG for their invitation to the conference, and thank you to all of you for your interest. Right, what I'm about to present is very conceptual and it's still in progress because this project has not yet come to an end. It's a research project by the University of Catalonia. This is the structure of my talk. I'm going to be very brief. There are many concepts, many technological and theoretical matters, and it will be difficult for me to delve into all of them, so I'll try to be as short as possible. First of all, objectives, methodologies, collective intelligence, artificial intelligence, contributions and conclusions. My colleague will cover the artificial intelligence section. Okay, as many of you might know, a huge amount of information includes the geospatial component. It is said that more than 80% of our everyday information handles or includes a geospatial piece of information. This means information can be geo-referenced. More and more, we use the geospatial component. In fact, there are platforms even for children. For almost all social sectors who may be trying to get familiar with these types of technology. The first law of geography says that everything is interconnected and the nearest areas are more related. This was said by Mr. Topla. However, if we apply the first law of geography to the real world, everything must be happening in one place on the planet and can be found, and if it can be found, it can be geo-referenced. Goodchild says that space and time are two concepts that mark all aspects in the geographic discipline. What does this mean? Well, it means that there are studies which involve territories in a very complex manner, but they can be studied through this method, through the information provided by geospatial data. Okay, right. What's the problem then? Well, for us to study a complex system, one of the recommendations is for the system to be studied from different disciplines. A multidisciplinary study doesn't mean studies are conducted from different approaches and then results merge together. Yes, that would be a multidisciplinary study, but the goal is to attain interdisciplinary results. That means that everybody needs to participate right from the beginning, from the moment variables are chosen till findings and results are found from their approaches. On that basis, usually studies are done from the perspective of a single individual who sets criteria. I'm not saying this is not the right way of doing things. What I mean to say is that subjects and complexity can be approached in a different way. Therefore, applications have been developed in the area of artificial intelligence. Usually the goal is to set patterns. A system is trained and educated for it to give us similar findings. This is used with satellite images, but the same happens. Usually it is the criteria of a single individual that are applied. I don't mean to say this is bad, but complexity should be approached with a different mindset, in a different way. And a lot is said nowadays about collective intelligence. Collective intelligence is a complex concept, because it includes many definitions, many concepts in turn. The same author, Pierre Levy is the author of the term collective intelligence. In fact, he has changed his own definitions over time. This is his latest definition. Collective intelligence is the capacity of human collectives to participate in intellectual cooperation with a view to creating, innovating, and innovating. It is in this sense that we want to conceptualize collective intelligence, in the sense that we can obtain information sources, process information, process data, and generate new information that can be useful, particularly to decision making. On the other hand, artificial intelligence is an older, better known concept with more agreement between authors. It is defined as the science and ingenuity of making intelligence, smart machines, especially smart computing programs. We tend to think about artificial intelligence as robots, but a computer program or a computer language is an application of artificial intelligence. The goal of my presentation is to show our latest developments in intelligence, in-depth design, development and testing of an application using i3Geo to try and articulate systems to integrate collective intelligence, artificial intelligence into a group. Similarly, concerning artificial intelligence, we want to derive patterns which, based on the collective's decisions, can help us see things that could not otherwise be seen. The methodology, roughly speaking, it's very much like this. We have a database. We are doing tests with i3Geo in a dedicated server. i3Geo is an official product from gvSIG. It is a Brazilian product, and it has lots of capabilities and functionalities which we believe to be very good for our project. It integrates a lot of technologies, and it so prevents us from having to start from scratch. It integrates map server, JavaScript, open libraries, and all of them are open libraries, which is very good. This tool allows us to publish geographic information on a portal, and at the same time thanks to an extension on gvSIG, which gives us access to the database because there is interaction between i3Geo and gvO. We managed to exchange information to a great extent. This information is then analyzed by a group of experts who, using a questionnaire online, make a number of choices in specific areas. And then this is taken to a database table, and well, every time a point is chosen on the map, a matrix is generated with all the elements of the information layers of that place. That matrix takes the values on all levels, starts an algorithm, an artificial intelligence algorithm, and returns to the database. More particularly concerning collective intelligence, we have two existing tools. One is a methodology and one is an actual tool. Vector Consensus is a tool developed by Catalonia's university. It is intended to find consensus between specialists in the same area. It is used in the medical area in Catalonia by Telefónica, the telephone supplier. This platform is based on a survey, and well, it was modified on the basis of a Delphi real-time method. The Delphi method includes rounds of questionnaires, and then feedback is done by answering the questionnaires or the surveys and by doing corrections. You can see the platform of Vector Consensus. It is real-time. People answering the questionnaires for this particular place can see their opinion about a particular question. The green line indicates the average of the group's opinions, and the shadowed area shows us the dispersion of the standard deviation in this case. A particular feature in comparison with Delphi is the fact that when the experts log in, they can actually identify the level of speciality. For instance, if they're going to work about the environment, they may decide to say that they are more better prepared for opinions about the environment than on sociology. So before these charts are published, their weights are pondered. And we are using a spatial version of the Delphi method designed by gvSIG and Pacinelli in 2011. They asked a group of experts well, they wanted to know where the likelihood of an earthquake could happen in 20 years' time. They were given all the elements, and these experts would answer. I've got to say, one of the main features of these surveys is that all invited experts are anonymous. They are all experts, but they don't know who is participating. So on a map, they place a point with a likelihood of an earthquake, and by means of a statistical method, by means of an algorithm, a circle is calculated which at least covers 50% of the points marked by the experts in the second round. All participants are shown where their opinion is and where the circle is covering 50% of the opinions of the rest of the group, and then they are invited to participate in that group by correcting their opinion and placing their opinion near the circle or in a near place. Or they may say, no, I don't agree at all with the circle. I don't think the earthquake is likely to occur there. And so it gives them an opportunity to argue and discuss things. The aim is for the circle to be more and more defined. It becomes smaller until the highest level of consensus is reached. The smaller the circle, the greater the consensus about the likelihood of an earthquake, according to the experts. Both methodologies were applied together to be able to launch an online questionnaire with all the information which might be deemed necessary to ask participants, to ask experts to put forward proposals concerning a number of things. They are to be given as much information as possible. In this case, it is for an environmental discussion. They are asked about the current situation, the current location of a place, and they are also asked for the forecast. Let me give you an example. Where is the highest degradation caused by humans? Obviously, the question needs to be focused on a particular place. Sorry, I'm going very quickly. But anyway, the question needs to have a physical boundary. And the second question, the question was, where do you think the area with the highest human degradation is? The participant would click on a spot here, for instance, and instead of using a circle on a real-time basis, he or she answers and shows his or her opinion on this chart, and he or she can see how much in agreement the person is with the others. So it is an opinion system, real-time, though it is not synchronic, which means that opinions can be seen real-time. If someone were to change his mind or her mind real-time, we would also see the effects on the average situation. And this offers many opportunities for analysis. The system is supposed to include experts from different disciplines. If someone is really specialized and willing to do a more robust analysis of the situation, we are designing an extension for gvSIG which will basically do what I show you. On the screen, you would be able to open an answer panel and download the cartography in such a way that by using this gvSIG tool, a person who is highly specialized and familiar with these tools could download the map and do other things. 2 minutes, okay. Right, artificial intelligence.
So we have very little time, so I'll tell you about the part of artificial intelligence. We define that artificial intelligence has two main fields, which is the computational intelligence, which is trying to adapt human thinking to machines, and automatic learning, which is doing that in an automatized way. Learning and teaching. From here we have many algorithms, and then we were choosing that of artificial neurons, artificial neural networks, At the beginning of the 90s, different algorithms were used, applied to the processing of spatial information. This offers us a good support in our research according to precedent research methodology. Here we have some concepts. The SIGs integrate statistic tools in order to carry out analysis and prediction. We could think that this is overlapped in the field of statistics. We shouldn't reject the statistical methods because they are complementary to it. The difference is that artificial intelligence studies problems with a very high level of computational complexity. This is the added value of artificial intelligence. The algorithm that we have is a neural network, multi-layer neural network, and that works by layers. The entry layer, an intermediate layer, and the output layer. And previously, we pre-process the data in the database. Those which are pre-processed are entries. Here we have hidden layers. And this is what we have to make very accurately in the test with the system. The result, we know it. So this type of learning process is called back propagation with a supervised algorithm. That means that we know the input data and the desired output. There are other methods, of course. This is an iterative process, and there is a set of data that get in, and we calculate an exit. We compare that with a desired value, and we calculate an error, and this is iterative. The error comes back so that from the learning process can predict with new data, can do the this and avoiding this noise that could take place in the new data for the tests. So we are going to continue. This is a screen, which is an output screen. The results could be two screens. One is this one that gives you the result regarding the convergence in the opinion of experts. This is a report that you can see on the screen, or you can print in such a way that decision makers see where you can find the points in which they were converging. And on the other hand, with the matrices, we would have a sampling of all the areas which have similar features to those which were indicated by the expert group. This algorithm places us in the rest of our area, all the area that have similar conditions, all the geospatial information that was in that place. I'm referring to vectors and raster. The contributions are that decision making is done more efficiently because many criteria intervene in these studies. And finally, that this is an instrument in order to analyze complex aspects of territory, trying to promote the consensus generating approaches, intelligent approaches. So 3Geo was useful, and gvSIG because with no much experience, no much time, we were able to achieve a lot, an excellent result, and that has only been possible thanks to these two technologies, i3Geo and gvSIG. And as this quote mentions intelligence as the tools, the cutting tools improves when we confront them to a higher hardness.